Stepan é engenheiro de software na equipe do Facebook. Ele trabalha no M, o assistente pessoal para o Messenger. Em sua palestra, Stepan irá dissecar o crescimento de uma grande aplicação React com os erros técnicos iniciais que podem ser cometidos para superar barreiras de desempenho e introduzindo a tecnologia necessária para manter o desenvolvimento produtivo.
¿Estão prontos? Vamos nessa! Hey everyone, my name is Stepan. Today I'm going to talk to you about scaling React applications. After this, in exchange, I want you guys to teach me Portuguese. Todo bem? Okay, good. So, a little bit about me. I work at Facebook on M, which is a personal assistant for Messenger. We use machine learning to make it so that whenever you ask M a question, we can figure out what next steps to take. Now you might think, what does machine learning have to do with React? You'd be very surprised, because I'd say about half our code for the last 3 years has been written in React. And I think a lot about how to scale these type of projects that we're working on. And to kind of get into it, right, when we think about scaling React applications, what do we mean by that? Well, do we mean that you just load many React applications on different browsers? No, that's not the job of React, right? That's the job of your team on the back end. So what do we mean when we say scaling React applications? Well, it can be scaling your team, right? When I was starting out on React, we were working in a startup, and it was just me and one other person. And when we thought about how easy it was to get started on stuff, all we had to do was just look at each other, and then we could push a feature out. But as people started getting added into the team, we started noticing something. We noticed, oh man, it's getting harder and harder to start something. In order to even just experiment, you have to understand the entire structure. Even just literally things like loading your app starts to take longer. And eventually you're going to ask yourself, man, maybe this is just what it's like to get into a large application. But then something really bad, like something happens, right? All of a sudden, you make less output than before when you had a lower number of engineers. This is when people start telling you on their team, you know, I don't even experiment on this app anymore because it's just too tiring. It takes me 15 seconds to load the browser. I don't understand how anything works. There's 5 different libraries. So, when output goes to the right, and we're noticing that these engineers are getting worse and worse, what's going on, right? People stop working on our product. And ideally, what we want is anytime output starts to slow down, we need to stop and think, okay, what's going on? Let's rethink our paradigm, and then get a higher output again. Then it's going to happen again, and then we get a higher output again. So one aspect of scaling front-end applications is scaling your team. The other aspect is scaling your product. So as you start your application, all right, we started noticing something. One way to think about it is line of code on the left and the number of features on the right. When you start working with somebody, you don't want the graph to be linear. You don't want to make it so that any new feature you add, you just have to add the same number of code. Because what do you think is going to happen as the number of features get larger than can fit anyone's head at all? Even one feature stops fitting in somebody's head. You'll end up having to rewrite it, right? And if we remember what happened to Netscape because they rewrote their application, we don't want that for us. So the second aspect when we're talking about scaling React applications is scaling the way that we build this product. When we add another feature, are we adding the same amount of code, or do we have abstractions in place so that it starts looking like this? We start increasing our loc. We're about to hit some line of code, and we say, oh, wait. Let's rethink. Let's re-abstract. What's the essence of the problem? We rethink it, and then we go down again, and we continue on this kind of path. So the goal is to scale the front end. But why do we want to scale React? Why do we use React at all? And just one thing I want to understand is, could I get a raise of hands for who uses React here? Nice. Okay. So there's a story. You guys can't leave if you don't use React at the end of the talk. No leaving. Why do we want to choose React? So I'm going to go briefly over that and what problems that solves, and then we'll go over how to go past React into what's next. So to understand why we want to do React, why we want to use it, we have to go back in time. Back in time to 2010. The year of Justin Bieber and the year of Backbone 0.1.0. So what happened in 2010? In 2010, there were a bunch of applications coming in where we were starting to say, look, we want to build everything on the web. We want to use the document the way that people used to use applications. Google Maps was serious business, right? So we started thinking, oh, okay, like we can't just use jQuery everywhere because it's just getting hairy. Let's start building a little bit of abstractions, right? And the way that it would work at this time is if you want to build something like just a message list. Here, all we want to do is show the number of messages we have from our friends, and we want to show the list of these messages. We also want to be able to click a message and see what's inside, right? Here's how it would work in Backbone. We would say something like this. Okay, the message was received. Now we'll trigger an event on our model. We're going to increment the unread count. We're going to add a new message in the messages view. We have to check, though, are we focused on this friend? Because if we're focused and the view is open, we obviously don't want to increment the unread count because you're already seeing that message, right? So we want to decrement it in this case. So the thing we're seeing here, right, is these words, increment, append, decrement, replace, right? Now I want to give you guys a little challenge. So we saw the app. Now I'm going to run a few steps, and you tell me what you think the app will look like. James gets a new message. The focus switches to Jenny. Jenny gets a new message. So remember, we don't want to increment the unread count. Jack unfriends you. Merda. We didn't think about this, right? And the problem is our brain doesn't work this way. We don't start with like some initial model and then apply changes onto it and then remember what happens next. We just look at the state at each position and we know it should look like this, but you don't know how to go from one place to the other. That's not how our mind works. So the big problem that React was trying to solve was to keep the DOM in sync, right? And I'd argue that this is like 30% of the problem of scaling your front end. Because what would happen at this point is when you had this type of application, you'd start out, you'd say, oh, okay. Just to kind of talk about this problem a little bit, in order to keep the DOM in sync, before React, people were really having a lot of trouble with this idea, right? If you look at to-do MVC, which is just a way for people to show you how to solve this problem, you'd see this. There's a lot of options in JavaScript to try to solve this problem. I couldn't even fit it at, like, if I did command minus, it's too much, right? The way that this ends up happening is, as you start, right, you say it's okay. Oh, okay, I can understand how to go from an unread count to a not unread count, right? But all of a sudden, you have to keep track of the unread count, the open message, and then on the sidebar, you need to also have some other unread count. And then eventually, you hit a wall. You don't even want to use your application anymore. It's just like, it like gives you bad dreams, right? That's not what we want. So let's go forward in time a little bit. I reversed the diff. To the age of Daft Punk and React. So, what did React try to do? Instead of managing how we move from one place to the other, we just said, given a piece of state, we tell React how the UI should look like, and then React figures out what to do next. So in this example, we have a function, friend notes. It returns a div. This is pretty easy to read. That has a header. You map over your friends, and then you check if it's an active friend or not, and then you show one or the other. Now, what makes this pretty cool, right? The first thing is that it's declarative. And what do we mean by declarative? We mean this. Here, in order to go from a focused friend to a message, we don't say how to go there. We just express the idea that if the friend is the active friend, we need to show the message list. Otherwise, we need to show just a text. And we don't have to say, okay, whenever the active friend changes, remove this element from the DOM and append this element from the DOM. We just express it. Second thing is that it's very easily composable. So before, right, who here has used like handlebars or EJS and stuff like this? Okay. Now you guys will remember, right, that I kind of feel sorry for the guy that invented essentially handlebars. It's because he started out thinking, okay, I just want to I just want to express some items from JavaScript into my HTML. And then we thought, okay, well, what if we want to loop through some items? Okay, we have to invent something. Let's call it like each, some like double squirrelies there and double squirrelies here. But then somebody says, what if we want to filter it? And then you have to invent something else in order to be able to filter it. So what these people were doing was creating a language to allow you to compose your views. But this language already exists. It's JavaScript, right? So what React allows you to do is it allows you to use the power of JavaScript to compose your components. Here I'm using friends.map, which is a function that everyone knows, and then I render message list through it. And the last thing that it did, which is a little bit tricky and interesting, is that before you'd have these views in a different file, and then you'd have view models in another file, these templates and views. And the problem was that you need to get some data that's derived, like the unread count, right? And you would put that in your view model and then pass it into your template. But in this scenario, anytime you change the template, you need to change the unread count. It's very tightly coupled. But they're in different places. So for an engineer to understand what's going on, they actually have to check two different files. What React said is, okay, like, let's stop doing that. We'll let you express this transformation in JavaScript. So React made things declarative, composable, and cohesive. And I think this solved the first problem, which is keeping the DOM in sync, right? So what's next after that? I'd say that's about 30%. How do we go further? What are the other problems that we have? Well, we can kind of take a look. This is, you can imagine, your application. And each node in your application represents some item, some component. So an example could be a header, a login item, some other thing, and then they all compose each other, right? Now, the problem is, as an engineer, I want to be able to reuse some of these nodes, right? If I have like this like counting badge, I don't want to just use it for the header. I want to use it for the sidebar. I want to use it in as many places as I can, so that if we want to lower that requirement, right, the LOC requirement, we need to be able to reuse our components. And the second thing I want to do is I want to make it so that my team members can work on this app without us stepping on each other's toes, right? I want to be able to say the green people can work on the green thing, the purple people can work on the purple thing, and there's no merge conflicts. How can we go ahead and do this? So the first step is container components. So who's heard of container components? Okay, very cool. We'll go over container components. And I want to give props to my friend Huang47, who had a very good drawing of container components. He's my coworker, so I just copied it. Big props to Huang. Here's what a container component is. Let's say you have some component, you'd call it foo container, and within it you'd have another component called foo. And one of these components is responsible solely for handling data, and the other component is responsible solely for the UI logic. What does this mean for us? Why do we want to do this at all? And to just take a look, this is essentially what we're talking about. You have a component. This is how you would define a component in React. And then inside, you would return foo, and you would pass it all of its data. Why? Well, let's take a look at container components. They manage data. They don't manage UI logic. They're not very reusable, right? Because you don't really need to reuse business logic like this. Like if you have a piece of thing that's like very tight, like you're talking to an Ajax endpoint, usually you're not going to reuse that. And it needs tests. At this stage, you need to make sure that the data that you're getting is properly transformed. So this type of component is going to need testing. UI components, on the other hand, they don't manage data. They just show the UI logic. And based on this, they're very reusable, right? Because if they're not tied to your business logic, then you can move them anywhere else and just use them as pure UI. And in this case, I'll argue that they don't need tests because React already has tests, right? Why do we need to test it? You know, test that your H1 element is there because React guarantees you that it's there. Here's how just a normal app would start to look like. We'd say to-do app extends React component. We'd keep our state in the to-dos, and we would fetch, whenever we mounted, a list of all the to-dos. Then we would set the state. React would re-render, right? But when we think about it, is this how a real app would really work? Let's look at component did mount. Well, first, we need to keep track of an error. We can't have an app that just, oh, okay, didn't work. Well, refresh, right? And then we also have to make sure that we're loading something, right? We can't just, what if they have a slow connection? We have to show them some sort of spinner. And then we have to, remember to set is loading to false when we finish. Then it gets pretty hairy. Okay, like that's cool for like startup version 0, but what about timeout retry? What if you want to batch your requests, right? What if you want to filter your parameters? How is this going to work? Is this simple? It's not really simple. And this is the type of stuff that needs testing. This is going to get pretty hairy here, right? Now, what if we do this? We return up a UI component, and then we can define a UI component like this. We say, is this loading? Is there an error, or is there to-dos? We just write, if it's loading, return a spinner. If there's an error, return an error. If there's no to-dos, return an empty result. And otherwise, just map over the to-dos and return the task. So what's interesting about this piece of code is that because it doesn't have any UI logic, like you can get your designer to edit this code, right? Like, what is he gonna? There's nothing to break here, right? And what's the big power of this? If you remove all of the things that aren't reusable, all of a sudden this becomes something that you can put anywhere within your tree. So, has anyone heard of React Storybook? Okay. Imagine this. You have all these components, right? Now, every time a new engineer needs to start on a project, they can search through your code base and see what are these components that you've created. If you have a date picker, could you imagine what would happen if 2 people made a date picker? 2 people had 2 different algorithms for time zones? Like, that would just be crazy, right? This is what you can now do if you have pure UI components. You can say, look, here's how the to-dos look like. Here's all the possible states that they can have. An engineer can now search through your project and choose the right one. There's even a Brazilian project called Atelier. Woohoo! definitely worth checking out. So now that we create UI components, we can go ahead and we can share this piece of logic, right? And because we have container components, we can encapsulate most of the business logic in different areas of the tree. So what that means is now the red engineers can work on red, the blue engineers can work on blue, and they're very seldom going to need to come out of the green territory because they don't really take any data from the blue territory. And I'm going to make a note that this works best with Redux. I showed that you were keeping state in each component, right? But this was just to show you that this is how you should do it. This is usually a bad idea because you're going to need to have that state in different places of your app. If you use Redux, you'll essentially connect into this one piece of state, and then then you'll essentially have access to that piece of data. This is how it would look like. I'm not going to go too deeply into this, but if you have questions, we can talk about it after as well. So far, what we're saying is use containers to manage data, expose UI components, and keep a single app state. Now, what's next after this? Well, let's look at this, and let's look at what happens when React renders this, right? First, we say, okay, we've just added a to-do. Now we have to diff the entire virtual DOM. We have to find what changed, and then we apply what changed, right? Now, the problem is this works for simple apps, and this works for medium to pretty reasonably complex apps, but this doesn't really work in very complex apps. So what will happen when your DOM looks like this? Oh no, right? If we diff this every single time a key down event happens, we're not going to have a fun time. So what React allows you to do is to have a lifecycle method called should_component_update. So has anyone heard of should_component_update? Okay. Just to briefly say, should_component_update just says, hey, have my props changed or not? But the problem is the default state for React is return true. It says it always changed. The reason is it's impossible in JavaScript to know when something has changed, right? You can mutate willy-nilly, so React can't trust anything. It just says, okay, well, I don't know what to do, right? Now, what you can do is you can say, okay, like, I'm going to tell you that every time I give you some items, I will never mutate them, so you can trust by reference that everything works. So you can't do this anymore in this way. So if you say completed to do, if you said to do that is completed is equal to true, you're screwed, right? What you could do is you could return a new to do, and you can say is completed is equal to true, and then you'd use the spread operator essentially to merge the old to do with this new object, right? But the problem here is 1 year later, I'm going to say like it's your intern, right? But it's probably just us. We come in, and then we make a new function called addInfo, and we set to-do.info is equal to info, and we return this new to-do, and we think that all is great, right? Well, essentially the problem is the default is mutation. So the only time this is going to go wrong is the moment where like you have a horrible bug and you don't know why it's happening, right? The way that we solve this at Facebook is by using immutable.js. Raise of hands for who's heard of immutable.js. Wow, very good. Immutable.js provides us a bunch of nice data structures that we could use to create these new types of items. So we can say to-do is a map, and when we set something, it guarantees to us that to-do can never change. If we pass to-do into a function, the only thing that function can do is to create new versions of to-do. It can never change what was passed in. So now as an engineer, you can have complete confidence that whenever you see some object and if you give it somewhere else, it can never be changed. You can assert that those are not the same. But what immutable.js does under the hood is it does structural sharing. So if we set false back again, even the reference equality is going to be the same. The way this does it is something called persistent vector tries. I'll explain like a simple version. Let's say you have a linked list of items, and you want to just change the first item. What you would do is you would just connect onto the second item, and you'd be good to go, right? This is the essence of structural sharing. And the benefit of this is that it's robust by default. There is no way to mutate. All you can do is change what was previously set. And it's performant because it uses structural sharing. The final win, it also gives you these awesome functions. Reduce right, take, but last, filter not, right? These are functions that you can use to make your code more expressive and more comprehensible. The final win of immutable.js is records. So the other thing that can cause you issues when you're using, when you're building these type of applications is you create something, you say, oh, okay, my to-do as a body is completed in a category. And then all of a sudden, somebody else, somewhere else in the code base can add something to to-do, right? They could add like favorites or something. And you'll never know where they added it. You don't even know why it's there. You have no confidence that to-do will always look like this. When you create records, it essentially says, to-dos must have this structure. So now when you say new to-do, it guarantees you that is completed is already set to false, category is set to null. And then if you make a mistake, right, if you say is completed to true, it'll actually throw an error because it doesn't let you set items that cannot be set on this record. This gives you the confidence to say that any model in my app must look like this, right? At least the keys, at least you can be confident about the keys. So what's next after immutable? Higher order components and in general functional programming. So who's heard of higher order components or functional programming and stuff like this? Awesome. The entire idea is when you have an app where you share some piece of logic that isn't really related to any component itself, right? Let's say you want to connect to a data source, or you want to make some component draggable. Every component has the same type of way that it'll be dragged, so you don't need to re-implement this every time. So what people usually would do is to use mixins, but the problem with mixins is that first you get implicit contracts. So what I mean by implicit contracts is whenever you say connect store or whatever, or you say draggable, it can depend on some function within your component, and you can never know, right? You can define something, and then all of a sudden, the only way that you could know is by reading the entire source code of this module, right? The second thing is that they can have state clashes. Draggable can use item, and so can some other thing like connect store, and all of a sudden you'll get an error, and you'll never know why. And the third thing is performance issues. If you put a mixin into your component, you never know what it's depending on. Like maybe it's depending on some sort of mutation. And you have to, again, read the entire source code to be certain that it doesn't. What you can do instead is to use the component model to make an abstraction. You can have a function that returns a component. And in here, you can use the lifecycle methods, the state, all from scratch without having to interfere with whatever component uses. Then you can go ahead and inject what you need into component. So here's another example. I create draggable. I can create my function here, and I can pass it into the props of the component. And what this allows me to do is that it allows me to say, okay, with this component, I forgot what I was saying. So we're going to continue on. So the final statement is on JS fatigue. So the entire ecosystem right now is overloaded. We have a lot of new libraries coming out, and everyone's getting tired, right? But what I'd like to ask is that we focus on the fundamentals, right? Our goal is to scale the front end. So could this be a paradigm shift? Could this make it easier for our team to build this product? Could this level the playing field for engineers and designers and people on my team? is it worth it, right? If it is, then it's not really JS fatigue. It's just improving your team, right? Could this reduce iteration time? Could you make it so every new feature comes out faster? So in order to do this, my current suggestions are use container components, use immutable data, use functional programming. But there's a lot more to do, depending on how much more complex your app can get. So there's stuff like Relay, Redux Saga, and CSS modules. Now, do you guys know where we talk about this? We talk about it in the open source community. We talk about it in structures. And we talk about it in a new thing that's coming out from Facebook called Developer Circles. We have a team in Porto Alegre. If you go to this right now and you sign up, you'll be able to go and have meetings like this over and over again, talk about React, talk about other items, get connected into the community in Porto Alegre. And then if you're outside, maybe open up a developer circles in your own city. This is our way of kind of connecting with the community. And I'd suggest that you guys definitely try it out. Thank you.